continuing our gameplay for the lucky numbers. So as you should already have seen by now, lucky numbers is a game where you have like some cards from numbered 1 to 20, and then like okay, this so far now next what I want to do is I want to create the starting state where the deck will from the deck you will fly 4 cards into the respective 4 slots, okay, like this, and this will like be the diagonal that the cards will land on. So let us start coding this. Okay, so before we code this, actually I like to code the clover. So this clover should have a certain color, and it also should have a certain number. So let us see um, how we can code this script. So let's have a script called clover. Okay, so this clover script will basically be a script that will be placed on the clover itself that will be able to affect its color, image color, as well as the text. So let's try this. Okay, so public void set color, and we have oh oops I have a color 32 color over here. Okay, and because I'll be placing the script on the clover itself, so get component image dot color equals to color. I think that will work. And then we have a public void set number, and we have a number, this one. So over here we would have to reach out for. So let's have a public variables here. So over here the public variable is actually a text, my text, or public text my num. Actually, why not we just call it number? Then over here, because we use text, we need to use unity-engine.ui. Over here, when we set number, we will have this number.text equals to number.toString. Okay, over here, we should call it like num. Then we have a public void get number. Okay, so this is an integer because it returns the number itself. So this get number here, what we'll do is we will return the number. Okay, so this will be number text, and then we have private variables here. Private int my number. Number text. So we set the number. We will set my number equals to num. Okay, and then the number text we also get it. So once we get numbers here. Okay, so let's try. Okay, so this will be the Clover class. Once we instantiate the Clover class, we also will set the color and we will set the number. All right. So let's try putting this script on the Clover itself. I'll do it on the prefab directly. Okay, so this is the prefab. Okay, we go back to our scripts Clover. We put the Clover here, right here. Actually, to be precise, we can actually do this in the ball, but it's okay. We'll keep it separate. We will use a separate script for this setting. So this Clover will be here, and the Clover number text, okay, will be this one here. Okay, so we go back to the scene. The Clover in the scene, has it been updated? Yes, it has. Okay, so we do have a Clover view over here. Okay, so what I want to do next is I want to create an empty. And over here we got clovers, which will tell us where all the clovers are. Under clovers, oops, no, under clovers, which will be resets to 0, 0. We will then put this clover here inside. Okay, let's see. Okay, I haven't really set the number yet, but we will do that later. Okay, all looks pretty good. Okay, so over here, okay, okay, so this is how it looks like right now. So we have player one and a player two. Okay, this needs to be changed to player two. Okay, you can see that the width of this two here is also slightly different. So let's fix that. So the player one area, the player two area should be the same width. So let's see. Right, transform. Right. Maybe we set the width to be 300 for both player one and player two. How come there's a width for player two, but there's no width for this player one area? Okay, now we have the width 300. Okay, so we set the width here, and the height maybe set at 400. Standardized 300, 400 for both areas. Okay, and then maybe we'll have the title here as player two. Okay, now what we'll need to do is we'll need to have a game manager. So let's create the game manager right now. So game manager. Okay, before we create the game manager, in the event that there's many on the table itself, uh, in the event that there's many cards over here, we cannot use a horizontal layout group. So let's remove this component. Instead, we use a grid layout group. Okay, we set the cell size to be 50/50, and we'll align it to be middle center. Start corner will be upper left. Okay, that's fine. Spacing maybe 10, and then we'll have constraint will be fixed column count. So I think we will set it as 10. So let's say we increase the number of buttons. Maybe a constraint of 12, 11. I think 11 would be good. So if any excess, they will just overflow to the next line like that. Yeah, 11 buttons will be good. Okay, so this will be the table. I don't think we need a deck count anymore here, so let's delete this. And then, yeah, looks good so far. Let's see whether I spoiled anything in the game. It's important to check. So let's see. Okay, it's still moving fine. The movement speed could be a little faster. So let's change that. We go to ball and we change the speed to maybe 5. Still think it's a little slow, so maybe 10. Yeah, we want the movement to be like quite fast and quite cool looking. So let's try again. Yeah, looks good. Okay. So in fact, actually, this thing here would be would not this would not be shown to the player. Actually, this is just a so that the player knows what's the card to be selected, and then from here you can put into your grid. Okay, so let's go down. You can see that these are the things that will be selected later. Yeah, I like the speed. The speed looks good right now. Okay, so now what we'll do is we'll instantiate a deck of cards. Okay, so the clovers, okay, will be placed on the deck position. So in order to do that, we will need to have a in the game manager. Okay, let's take a look at what we need to feed our game manager. Okay, we need to feed it the table, this table cards thing. So that we can add the buttons to this table, and then we can also find the respective position to send this to. If you go to the table, you need to add the player one and player two grids. Okay, okay. I'm just thinking what's the best way to add this. So I think there's grids. We can just add all the buttons one by one. The table wise, maybe we can add all this, or we could every time when we shift it to the deck. Oh, sorry. Whenever we select the to put the card on the table, we can make the table have like empty slots, I guess. If not, I will have to make my table a huge button where you can click on there. I'm still thinking what's the best way to do this. If I move my card on the table, it must be an empty slot that I can click on it. Yeah. Should I just make the table only have 11 uh, cards? No. Okay, let me think about it. Let me think about it. How to program this. Okay, let's start with the denote the denoting of public and private variables here. Okay, all these are standard. Okay, then what we do next is we want to set our game objects. Sorry, we have a text first. Okay, so if we use text, we have to use Unity Engine.ui. Okay, and then this text will be the prompt text. Okay, so at the start text, something like that. Okay, so we also have the public button. Should I call it a button? Because if I call it a button, then it will, or I should just make all of them game objects. My button click, that one I don't need it. So actually, I should just make it game objects. Uh, Deck. We have a deck. Okay. Then over here we have a public game object also, but this is an array, P1 grid and P2 grid. Okay. Yes. Let's create a game manager. Type expected 12 12. Okay, let's create the game. We create we create the game manager here, and then we drag the game manager script inside the game manager. So then we have the prompt text. Where's my prompt text? My prompt text is at the top here. Prompt text, we have our deck, which is here. the button. We have our table. Well, give the table cards object. So over here we can control the buttons that are inside here. Okay, we will have the player one grid and player two grid. So the player one grid will contain this. Oh, let's make our game manager. We lock the screen here. So the player one grid will contain all these buttons here. You can drag it in. A player two grid will contain all these buttons here. Drag this in as well. Okay, I realized that I have one extra text I need, which is deck counts. Okay, because deck count is this one text here that I need to edit. Okay, so the deck count will be given by this text. So over here, maybe deck count dot text equals to 40. And over here, we will have a private variable int deck counts. There will be deck count text. Okay, so let's see. Game manager dot start not set to an instance of an object. Oh, my deck count text is empty right now, so let's put the deck count here. Okay, all's good. Okay, looks like it's going well. So you can see that it hasn't changed the behavior. It might be moving a little too fast, so we can change the speed. Maybe 7. I don't know. Yeah, something that is good. Something that is in between will be good. 7 looks good. Yeah, this looks pretty nice already. Make this move, and the card can move like that. Yeah, this feels a little cramped up. Let me fix that. So the deck counts should be slightly lower, I believe. So let's make it lower. This table cuts slightly too high, so maybe we'll make it lower. Yeah, if we do that, our deck is not aligned with the. So maybe in the deck itself, we could shift it lower. So what did I do? I shifted the table cards, right? So maybe I'll just change the deck count. This button here. I'll shift it down by 2, by 5, I mean. So this will be about 53, 43 then. Okay, now it looks okay, right? Yeah, looks okay. Okay, so now what I want to do is from the deck, I want to spawn out 4 cards that fly to the player's grid. Okay, so in game manager, I will need to. Okay, so in this ball here, it will fly towards the position, right? So we will need to instantiate Okay, so let's say I create a routine. So not routine, sorry, I create a function. So this one will be called uh, fly. Then I'll have a start pause and end pause, right? So I'll have a vector tree. Okay, so the function name is called fly. We'll take in a game object. We call it game object ball. Actually, by right, it's a clover. Should we just name all these clovers? I'll just call this as clover first, game object clover. And then the clover would fly from source destination to the end destination. But actually, we don't need the source destination, so we can just put the end destination. So, or actually, I don't really need to put the source and end, because I have this fly to position here on the ball. So, call it clover since it will be. Oh, but clover will update with this class. It's okay. We'll keep ball then. Yeah, it's fine. Yeah. So we will need to instantiate. Okay, let's just practice doing this. So Unity instantiate objects. Okay, so we need a prefab also. So public game object Clover prefab. So the Clover prefab will basically be the Clover that will instantiate. Okay, so let's put a Clover prefab into the scene itself. So the Clover prefab, I have a Clover here. Okay, but I would not want to use that. So we'll use the Clover prefab instead of this. So let's delete this Clover. Okay, so all the Clovers should be displayed above all of this. So maybe we could have a canvas, especially for Clovers. I also have to instantiate my Clover under this object, and then the table itself I will instantiate separately. Okay, let's see what the instantiate function does. So when you instantiate, you can instantiate the object you want, okay, the position you want, the rotation you want, which is normally nothing, and then the parents. Transform dot position, transform dot rotation. We want to instantiate, and then we want to put the parents. Let's use Clover parent. Okay, so let's. So the Clover parent will be here, where we will put all the Clovers under this Clover object. Okay, to make things easier, we will just manage all the Clovers from that object itself. So where's my game manager? Clover parent will be this. A Clover prefab. Okay, let's log this again. We go to our prefabs and just drag a Clover inside. Okay, so let's instantiate the Clover. Instantiates. Okay, Clover prefab. Okay, then what we need to give the position. So the position we can just take the deck dot position, deck dot transform dot position. Okay, because only the transform has a position. And what else do we need? Rotation. Okay, over here the rotation actually we gotten on the identity if I remember correctly, because we don't really have a specific rotation. And then parents, the parent will be instantiated all under the Clover parent, so it will be instantiated like that. Okay, so we would want to know how to access this Clover. Okay, so over here we have a game object current Clover, and then we instantiate this as a game object. Okay, then we have current Clover dot get component. Okay, because in the Clover we have two scripts. We have the Clover script and the ball script. Okay, so maybe we'll do this next. We'll just instantiate the Clover first and see whether it's instantiated. Quaternion does not contain identity. Okay, let's take a look. Quaternion dot. I remember there's an identity function dot identity like that. Yeah, so we take it from the back, and then we give it identity. Okay, let's see how this works out. Okay, this is the first time I'm doing like a game with moving objects. Cannot convert from game object to Unity Engine transform. Number 27. Oh, so when I instantiate this will be a transform, is it? Okay, what does instantiate return? Let's take a look. What does instantiate return? It returns an object. So actually, it is possible to instantiate as a game object. Yeah, why is it not able to do it? Let's take a look. Cannot convert from Unity Engine.game object to Unity Engine.transform. Okay, so does that mean that this current Clover is a transform? Oh, okay. The issue was with this deck.transform.position. Okay, get transform from game object Unity. Did I give the wrong object for deck? Because if deck was this button here, they should be able to get the transform. Oh, there's no transform component, there's only a rect transform. So when I did my fly to position, this ball, which is the Clover itself, is a rect transform. Okay, we have to debug this. Can rect transform be used as a transform? See, transform. Okay, so I guess what I need to do now is I need to do some form of transform here. Okay, so I'm not too sure why the deck itself is supposed to be a game object. Okay, does not have a transform, but let's just make it more explicit. Deck.gameObject.transform. Hmm, I'll just create a let's create a get position function. Then I'll just return transform.position. Not sure why I cannot access the transform directly, but I can just create a script in button click, and then in game manager I could just stack dot get component button click dot get position. Cannot convert from game object to transform. So in my game object deck, I will have this button click script. I can get the component, and then I can then get the position, right? Game manager 27116. Oh, is it the Clover parent that is the issue? Okay, debugging time. So this is a transform parent. Oh, I see. Okay. So this should be fine. Yeah, I was thinking from game object to transform should be fine. The problem is here. Yeah, in order to instantiate, you need to instantiate to the transform of the parents. Yeah, they should just make everything game objects. Yeah, transform is so confusing. Yeah, but transform is a sub uh, object within the game object itself that contains the position, so it's important. Okay, so I guess I solved the issue. I probably don't need this. Okay, so let's see whether this works. Cannot convert from game object to transform. Okay, let's remove this. Okay, actually, if I save this and I clear, oh, it cannot. Oh, is it the issue with Clover free prefab also? First is object original vector tree position transform parent. Okay, why not? Let's just create another line. Okay, we just take this sentence and repeat it. Okay, we put in another line like that, and in this other line, let's just instantiate the game object without any parameters, just like that, and see whether it works. And this doesn't work already, so okay, so this is a game object. Okay. Let's see whether it instantiates the game object. Where did it instantiate to? I see no clovers, if you ask me. Oh, is it because my game manager is not on? Yes. This ball can be deleted. Okay, let's see whether we instantiate a game object. Which is the clover. Where's our clover? Do we instantiate anything? Ah, there we go. It's here. Okay, we instantiated over here. We can just shift it and see whether we have it. Okay, so it looks like it's there. All right. And what we need to do now is we need to do this instantiate. Okay, I mean this one is done. Instantiate from the deck. Okay, and then we put it under Clover parent transform. Let's see whether this works. Let's go. Yes. Okay, do y'all see that? Do y'all see that? Okay, let's restart again. The clover flew from the deck to the center here, which is the behavior we wanted. Okay, so it looks like it's working. The instantiation is working. So now let's set the position. Okay, so over here, let's just call it set position. Okay, not fly to position. Okay, so we get the current clover. Okay, command all, and then we set the position of it to fly to. Okay, and what position should we use? We should maybe go to player one grid and then zero dot transform dot position. Okay, so it will fly to player one's grid. Okay, maybe player two grid. Yeah. Okay, so that it can fly further. Okay, let's see whether it works. Okay, since I changed the name, I need to change the name of that function in all other codes. Okay, let's see whether it works now. Okay, so it's supposed to fly towards the position of the grid in. Okay, so okay, it looks like it did not go correctly. Okay, now we need to debug why, because quite clear that we go to the player 2 grid. Okay, let's try player 1 grid and see whether it kind of works. Okay, so there's a little bit of offset here. I have a feeling it's because I call it at start. So maybe if I call this in updates, could it help to, because maybe at the start we haven't really got our grid layout working yet, so maybe we cannot do it at the start. Let's just try. Yeah, so it's an issue with, okay, but actually we will need to call this at the start because so we will need a way to do a force grid layout position in Unity. Yeah, so people have done like coroutine to wait for the position. pause needed layout update. Yeah, I have a better way to solve this actually. I mean, since nothing will go to the table at first, you know what? I could just remove the component for the grid layout group, and there will be no grid layout update at all. But that's not exactly the best way to go about doing it, right? So maybe we could have a refresh position right at the start to help people to help them refresh the position. So public refresh position. So what we do is for each game object in tag in p1 grid object dot set active false, then object dot we, we do what they told us to do, which is set to false and true. Okay, I wonder if I could just concatenate to okay, let's see whether it works. Oh no, type an identifier 34 28. Okay, let's just do it separately then. Yeah. P1 grid, P2 grid, type and identifier are both required. Okay, let's see C# for each. For each this isn't it already a game object? Oh, it's a void refresh position. Okay, so maybe that's the reason. Invalid expression in. There should be close bracket missing, is it? Public void start refresh position for each. Say semicolon expected 934. Okay, let's see. Seems to me like there's an issue with the word in here, but it should be okay, right? For each with arrays, for each int I in this. Unless I just do a var like that. type and identifier are both required. Maybe it's the issue with the word object. Let's put to obj. Maybe there's a system word object that I cannot use, and so let's just try obj to see whether it works. There we go. I was thinking why this cannot work. It's just very weird. Okay, so we refresh the position of the so that okay so that we get the updated position. So let's see. Okay, it still did not work. Okay, so grid layout group position. Yeah, the alternative is not to use grid layout group. What's this? Coding game mechanics fixing UI. Okay, so now we need to fix the problem. Okay, because like the deck dot transform dot position, the deck position is okay, but I when I set the position to be the player one grid dot transform dot position, it doesn't really work. So yeah, how to get current transform position with a grid layout group object? Maybe I'll just print the position of the transform so that I know what it becomes when I start. Okay, so let's print it out. So the first one is all of them are the same. Oh, because are this the same position as my as the clover that is instantiated? Yes, it is. Okay, it probably means that I cannot do this at the start. Yeah, I probably don't need this refresh position. Okay, I probably don't need this. Okay, what needs to be done is at the start probably I don't instantiate the clover yet. Okay, we let everything go ahead and then we will do the clover update here. So over here, so maybe at the start we put game start equals to false. Then the update here, if game start, oh sorry, this one should be true. If game start, then we do all the update here, like maybe da, 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 something like that. And then we have this current clover. Okay, so I'll have a few. Let me just okay. Now this one just goes one makes one clover. Okay, essentially a clover at the deck and then goes to that position. Let's just see whether this works. Okay, so I do it not at the start. I wait for the thing to update. Hopefully, it will solve the issue. Late update maybe. If not, I'm just gonna turn off the grid layout group. If it's causing too much problems, I don't see why I need to keep it. Okay, I'm gonna turn off the grid layout group. It's causing too much issues. So that all this, yeah, let's just turn the grid layout group off. Yeah, I don't really need a grid layout group for this. Don't really need this to be an update. We can just straight away start with this. Game starts. We can do all this. Game start. We can delete. Okay, so what I want to do is I want my current clover to take on a certain value. So set color, set number. There's an easy way to do this is that I could set numbers from 1 to 40. Okay, so if it's above 20, then the color would change accordingly. So maybe let's do that instead of setting the. So we could do like num% by 20. Yeah. So when we do a set number, it will change the color as well. So if num greater than 20, okay, then the color will be this one. The color equals to color dot grade equals to num grade greater than 20 question mark color dot grade color dot blue, something like that. Yeah. So no, with one soup I can get my number. Okay, so that should do it. I'll just set my number here. So I just need to set the number of the clover when I instantiate it. So let's go set the number dot get component clover dot set number. Actually, I'm thinking whether I should combine this ball script with the clover script because technically, why not? I mean, there's no real benefit to keeping it separate, right? So let's put this here, and the ball. Let's put this here, so that we can just update one and then get everything from there. And then vector 3 target pause, we can put it here. This is actually a private. I don't really need private here. Okay, so like that. And then all the things here will just reference Clover. The ball button click will reference Clover also. All this can delete. We don't need all this screen to camera thing anymore. I spent 3 hours doing this. But it's good. I mean, in case next time I need to use it, it'll be easier next time. It's always about experimentation when it comes to Unity. Okay, so we are done. Okay, we have our position, which we will set to whatever position we want to go. Okay, we'll set a number as well. And in this case, let's set a number as 4. Okay, I mean, no real reason. I can set as 8 also. Yeah, doesn't matter what number I set. I just want to see whether this works. So get a component clover. Okay, since I can delete away the ball because I don't really need ball anymore. Everything is subsumed under clover. Okay, we go to our prefabs and make sure that the clover prefab, we remove away this script. Okay, so that should settle it. Okay, game start does not exist in the current context. Let's delete this. No more game start. Okay, so now what we will see is we'll see a clover flying, a number 8 clover flying from the deck to player 1 top left corner. Let's see. Oh, something wrong. There we go. Okay, so I would like to like maybe change the color for the two clovers. Yeah, let's go to the prefab. Okay, let's go to Clover prefab and then we just set two colors. Okay, we just manually set the two colors. Rather than color dot red, color dot blue, let's create our own colors here. So we have a public color 32, color 1 and color 2 because it's a two-player game. So if the number is greater than 20, then color 1, if not then color 2. Okay, so we have this. Let's go back to our prefab clover. And now we set the two colors we want. So the game background is green, orange, yellow. Let's see what two colors we want to choose. Okay, something wrong with this. Color 2 does not exist in the current context. Oh, I called it cool 2. It should be color 2. So let's just change that. A small tweak to the parameters and it should work. Okay, so now we have the clover. Okay, we have two colors here. Let's decide what color should I make the first one. Maybe something golden, I guess. I kind of like the goldenish color. Uh, Yellow, maybe yellow. And then just make sure that the transparency is set to 255. Many a times the transparency is the one that cause a lot of problems with debugging. So maybe the second one is blue and then like that, yellow and blue. Okay, so now when we start, we will see a number 8 in yellow color coming down to player 1's top left corner. Oh, wait, why is it blue? Oh, because, yeah, sorry, blue color. Okay, so let's, okay, I'm just thinking whether or not I should instantiate this as Clover. Then I could, because everything will be based on the Clover script itself, so I could just use Clover, right? Okay, let's go back to the instantiate. I saw an instantiate missile. Like that. So I just instantiate the Clover directly. Cannot convert unity.game object to. Yeah, I couldn't get it to work. So let's go back to how it was previously. Yeah, we could do our set number and set position again. Okay, so I would like to just do a quick function here to set number and position for. So what we can do is set num pos. Okay, so we can call a function deck to grid for the initial part, then we could have basically a number 8, and yeah, maybe over here we could just have it as grid. Okay, we combine player 1 and player 2 into one whole grid. Okay, so let's go to game manager. Where's my game manager? Here. Okay, let me just make all the grids into one. E1 grid does not exist. Yeah, that's because I'm gonna change it all to grid. So like that. Yes. So this here will be changed to just grid. And then in grid, let me just lock this. In grid, I will just put all these buttons here. Oops. Like that. Plus all these buttons will be combined into one. Yep. Okay, so our grade is 32. So what I'll do next is I will have a helper function called deck to grid. Okay, and then we can set the number that we want, and then we set the position like that. So maybe deck to grid 8. So it'll be 0. The diagonals will be 0, 1, 2, 3. Okay, so let's just draw it out. Okay, so the grid will be like this. So the grid will be like that: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are the indexes for the grids. So that, it's easier for us to visualize how to go about doing this. In the square grid, these are my index. So this is the number to instantiate. And then this will be the grid position that I will go to. So I'll go to 5, back to grid. Okay, maybe you try a different range of numbers, Yeah. 23, 10, and 30, 32, 15. Okay, so maybe we can do this for I int I equals 0, I smaller than 2, I plus plus. So actually I'm just looping through this twice. So 8, 5, 8, 0, 5, 10, 15, and then I'll do a plus I times 32 because that's the number of grids for the next player. So we should see quite a lot of grids. So we will instantiate this one time for player 1 and another time for player 2. So that's the idea. Okay, so this will be the clovers to instantiate. Okay, so now we need to create our deck to grid function. So this function instantiates a clover from the deck and brings it to the grid. Okay, so how do we do this? Deck void deck to grid, because we don't need to return anything, is a void. Okay, and then here we'll have integer number and integer position. So we can cut and paste this thing here. Wait, integer position. We can cut and paste these 3 lines because this is what we want to repeat. It's called refactoring the code. If you realize you're going to use the same code again and again, you can consider doing this refactoring process, which will make your code neater, okay, rather than just repeating the same line a billion times. You could just refactor it, put into a function. You can call the function a billion times, but you write way fewer code, okay, because we can repeat the same lines of codes in the function, and outside you can just call something like this. In fact, if I want to do like 0, 5, 10, 15 in an array, I can also look through the array and do this. Okay, so from the deck, okay, and then we have a current Clover.get component, Clover.set number, and this number, guess what we're gonna set it as? We're gonna set it as num, and here the position, what do we set this position as? It'll be grid pos. That's all. And these are the numbers 8, 15, 24, and 32. Later on, what I'll do is I'll create a way to randomly pluck out one number from the list of possible numbers. Should have on the aircon. I have a bit of runny nose. But yeah, I only on the aircon because I didn't want to on my fan, which will be create a little bit of noise for the stream. Okay, so let's see. Oh. Index our bounds of the array. Oh, I only have 32 numbers. Sorry, the grid size the grid size is only up to 16. Yeah, this shouldn't be 32. This should be 16. 16 and 8 times 16 times 16. So yeah, this should be the way to do it. Yeah. So I should have the four diagonals being spread with the numbers if this goes well. Oh, look at that. It looks pretty neat actually. Do y'all see that? Do y'all see that? Let's do it again. Let's do it again. Ready, get set, go. Oh, okay, but there's something wrong with this. You see the number here is like a little big. Okay, so if let's say I were to click a square now, it looks like with this clover here, it blocks the ray cast. But it's fine. Let's click an empty square. All of these clovers will fly here. Oh, it's only one. Okay, okay, button click. Oh, because it only finds one clover to do it. Yeah. Okay, so it means that there's an issue here. The clover is actually blocking the raycast. Okay, later we will have to solve this issue. But as of now, the starting grid, there's also another issue that needs to be solved. Is that if we were to transit to a second clover, which is like this color, 24, 32, like that, it kind of doesn't change the numbers. Okay, something's lagging here. Okay, that kind of doesn't change the number somehow. So let's see in the clover itself, my number equals to this. Aha. Okay, but I used num here, so it should be fine now. Now when it splatters out, it should splatter out nicely. Okay, let's see. Yeah, so you can see. Okay, so now what we want to do is we want to create an array. Okay, so let's go to C# array. Okay, I want to create an array with the numbers 1 to 40. So one way to do this will be to just like list out all the numbers one by one. Another way to do this will be to yeah. So maybe why? I mean, unfortunately, there's no such thing as like a, a list range of something like Python. So we have to probably create this array ourselves. We'll have to list out these numbers 1, 2, 3, 4, 5, 6 ourselves. Okay, I'm just thinking whether there's a way to add stuff to an array. Okay, I only know you can do that for lists. So maybe we would like to use list instead. So C# list, because array is a immutable, like you can only have a fixed size. Okay, you cannot change the size, but list you can. So we can create a list and then we can add the elements in. So how do we add elements to a list in C#? Let's take a look. Add. Okay. So simple. We have a list int deck. Okay, I don't. Oh, this is under Clover, wrong. I should put this under game manager. So in game manager, list in deck num. Okay, we already have the game object called deck over here. So I would like to call this deck cards, maybe. Deck. It would be easier to call it deck actually. Uh, deck num maybe. Yeah. Equals to new list int like that. Okay, so it will initialize with an empty list, and at the start here, okay, fill up the deck. So deck num for int I equals 0, I below I smaller than 40, I plus plus, because there's 40 cards. Okay, deck num dot add I. That's all. Okay, then over here we need to we need to randomly take out remove card. Let's call it remove card. Yeah. Actually, we should call it remove clover because everything is a clover here, right? It's not a card. Call remove clover, which will randomly remove one element from the array. So maybe we call it clover deck clovers. Deck clover. Yeah, let's call it deck clover. Okay. So we have a function called remove clover. This one will return an int. Okay. So remove clover will basically pop a random element from the deck. So how do we pop a remove random element from list in C#? Let's try to Google this. How to remove a random item from this list. So suppose we have a list like this. Okay. And then I want to remove a random element. Is there a random function? Random.next. What's a random.next? Okay, I don't quite understand this code. So what we need to do is take random.next and take the list counts and then add in this index here to the chosen items. Okay, let's search what's random.next in C#. Non-negative integer that is less than the specified maximum. So yeah, I guess random.next is fine. Yeah. Okay, so let's do random equals to new random. So we set our new random. The seed can be any seed, doesn't matter. So random.next. Okay, we have a deck count. So our deck is deck clover dot count. Okay, we have an index. Okay, so we want to remove this index. Okay, remove element from list C#. Okay, I want to remove that element by index. So remove at. Okay, so what we do is we will store the value of whatever we are removing. So I wonder if this remove at or is a void. So we need to store the element first that we are removing. So maybe we have another integer element to clover to remove equals to that clover index. Yeah, and then what we do is we will remove at, so that clover dot remove at index. Okay, and then we'll return the clover to remove. So this will return us a random number to be removed. Let's try it out. We see whether this works. So if this works, we will get 8 random numbers. Okay, as usual. Okay, random does not exist. Actually, I don't have to use this random.next because Unity has a random inbuilt random element. It's called random.range. Okay, and then in random.range, okay, we can give it int min and int max. Okay, so this can be like 0 comma. So we can actually use the inbuilt random.range in Unity like this, 0 to that count. So we can do like this integer index. Yeah, because in order to avoid confusion with native methods in C sharp, Unity actually has a few inbuilt methods. We can use, in this case, random.range to do it. Non-invocable method, game manager.deckclover. Okay, line 52. Oh, oops, wrong brackets. Okay, we want to access. Oh, wait. This is not exactly a list, right? This is, sorry, this is not exactly an array. How to access element in list C sharp. So we want to get by index list.get. Oh, actually, we can do this also. Yeah, okay. So it looks like they have already did an overload for the list method. So I could just reference like that. I don't have to do that clover.get index. Okay, let's see whether this works. Oh, nice. Okay, it's 3, 16, 14, 13, 15, 10, 10, 2. Okay, let's see again. Bish. Oh, very nice, very nice. Okay, I zoom out a bit for you to see. Okay. Oh yeah, oh yeah. Look, when you play, wish. Beautiful, beautiful. Okay, so actually I have this deck count over here. Okay, I would like to update my deck count as I remove my cards. So I can start with 40, and then every time I remove Clover, okay, I'll update the deck count also. So like this, deck count text equals to deck counts dot or equals to deck clover dot count dot to string. Okay, we need to convert this to a string. So this should be dynamically updated. As I remove my cards, you will see it splattering. Okay, I didn't really see it going down, but I guess everything happened too fast. Okay, so to just make sure that it's working, I'll just start with the grid of 40. So we go to our deck count. We set it to 40. Okay, and then I'm gonna play this, and then you'll see that it will become 32 after this happens. Okay, very good. So the next thing that we need to do is that we need to sort of sort. Okay, so we have this remove Clover, right? I mean that is actually awesome. However, we need to kind of sort the clovers. Okay, so how do we do this? Okay, sort a list in C sharp. Okay, so there's a sort function already. We can just use that. So in a list like this, we can do dot sort. Okay, that's great. Okay, so how do we do this? How do we do this? We're gonna need a few more lists. Okay, so we're gonna need a few more like list int p1 starting list in. Okay, so over here we will just choose randomly four clovers for player one and player two, and then we will sort them out. Okay, we will, because we want the clovers to be in increasing order from over the diagonal. So let's do this. Actually, we don't need two lists. We could just clear a list out clear. Now I remember there's a list out clear. So we could do this. Uh, holding. So we have a holding deck dot clear, and then for here we cannot use I anymore. We have to use J because I used I earlier. So I J, okay, for J like this. Okay, holding deck dot add remove Clover. Okay, and then what I'll do is I will uh, okay, so this just adds in, okay, clovers to the player. Okay, and then what I'll do is I'll do holding deck dot sort. Okay, and then over here we can just put like holding deck 0. Yeah, so this should sort this in increasing numbers, increasing values. Let's see whether this does the trick. Okay, so it's increasing values. Here, not quite. Okay, it seems that the increasing value does not take into account whether it's like yellow or blue. So like over here, 1 to 8 is increasing, yes, but 6 is not. So maybe in the sort, we need to sort with criteria that is slightly different. So what we can do is we can sort. Okay, where's my sorts in the list? I love this inbuilt functions. Yeah, all languages should have this kind of inbuilt functions. It makes life easier for people who are trying to program. So do a sorts, and then maybe I have a comparator that I will sort through a Okay, I know how we do it. We sort two decks. Okay, so you have like that, one deck, and then you have another deck. Okay, okay, you have another deck called order deck, and then basically the order deck will be a copy of the holding deck, just that it is so we have a we remove a clover, we call it clover num, we add this clover num, and then over here we have order deck dot add. Okay, so we have two decks. One is the order deck, uh, which were ordered by the number itself. Yeah, but that doesn't tell me like which is the smallest, which is the largest. Or you know what? I can just do the we could order by. Okay, maybe we don't have an order deck like this. Maybe I could use a lambda order by. So we could do can I do this? Let's see. Yeah, let's use the order by. It's more Pythonic, and then we order by the number percent 20. Let's see whether this works. So much easier to do this in Python, actually. Oh, okay. Aha! There we go. The order by works. Awesome. So you can see that it's really ordered by the number percent 20, and that's exactly what we have to do. So that should be it for the beginning. Okay, so this deck here actually, I realize we won't be needing to put anything in deck. So maybe we could just have a. So just for this deck alone, okay, just for this deck, this button here could be a darker color, like this, and then the deck counts. Okay, the deck count can be anchored at the center actually. Stretch, center. Actually, I could make the deck count here, right? I don't need this deck count. I could use this text as my deck counts. And for that, I can just update my game manager because I won't be needing to click on the. In fact, the deck doesn't even need to have a button, right? Well, actually, you need to because you need to click on the deck to take a card. So we could have the deck count text to be here. This one. Okay, let's take a look. Let's take a look. How come it seems like it's not sorting anymore after I change the deck count? Although tell me this order by doesn't change the order. Yeah, it seems like it's not sorting. Maybe just now was a fluke. Yeah, let's just. I thought this order by was working, so maybe print that. We could print the holding deck. See. Okay, now there's a zero. We shouldn't be having zero. We should be having 20. So yeah, somehow the order by worked only for the first run of this code. Okay, let's just try order by XX. Okay, this should order it by increasing order. Okay, something's wrong here. Something's wrong here. So okay, let's just do the sort. Okay, we do the sort method, and we see whether it works. Okay, let's just try to sort this out. Yeah, the sort method is working. Okay, it means the link queue order by method has some issue. Link queue order by, does it modify the original list? Maybe I'll use the sort method like this. A, B, sort by this. Okay, something like that. Yeah, it's comparator operator. I do a sort with a comparison. Beautiful. It works. Okay, so now the other issue to fix is that the number over here, okay, in the Clover, I divide by I do a percent 20, okay, but the number over here should be a percent 20 plus 1, okay, because we want to have clovers that are from 1 to 20, right? The alternative is if I do a percent 21 instead, okay, and then like that, because there's only two sets, right? So here will be percent 21 also when I do this. Okay, and then once I add the clovers, I add from 1 to 40. Okay, so let's see. Invalid token 31 greater in class 28. Oh, I took out the bracket. This should be good. This should be good. Okay, so I think this is good. I don't need to print this anymore. So this should, using the inbuilt sort method and the comparator, I pass in the lambda function for the comparator. This should already work. So let's see whether this really works. All right, here goes nothing. Very nice. Okay, let's try again. Let's try again. So you can see that the cards are already going one by one to the both players like that. Oh, why is there a zero? Okay. Looks like it's sorted. The only problem is that sometimes there's a zero coming out. Shouldn't be the case because in my deck itself I don't have a zero. Oh, number 21 will be given. I know why. Number 21 will be shown as a zero. Okay, so over here, maybe what I can do is like that. If it's greater than 20, then we subtract by 19. That's like 21 would be 1. Like that, yeah. So everything will be greater than 20. And over here will be 0. So 1 in the new deck will be a 0. Is there a way to... Okay, so I think it would be more straightforward to just set the deck from 1 to 0 to 4 like that. Then we just use a percent 20 to sort this. Okay, and in the clover itself, okay, if the number is 20, it means it's a 1 for the next. So we could just do a percent 20. Yeah. Okay, and if the num is greater or equals to 20, and it will be 20 will be the new color. Okay. Plus 1. Yeah, so if we set the number to be like 7, actually it means set it to be 8. That's the way this works. I think this is fine, I guess. Yeah. So the number here and the deck number would be, so the deck number would be 1 less than the original, I guess. Because if not, we will have problems here. Yeah, I still don't like it. Yeah, I think it's better to keep the deck with the original ones. And then I will just do a minus 1 and a b minus 1. So the deck itself will still be the 1 to 40. And then over here, I just need to do num minus 1, this one 20 plus 1. And then here, if it's greater than 20, then like that. Okay, so everything here will be okay. It's just a matter of programming this to show the numbers 1 to 20 in one color and 21 onwards in a different color. And let's try. Looks like it's working, isn't it? Ah, quite like the way it's flying. And then after that, I'll need to put another number here. Okay, so I think we are done for now. Uh, Still some more improvements that needs to be done for this, but I'll continue later. And yeah, I'll see you again soon. Bye.